Welcome. Our team is here to discuss the challenges and opportunities presented by the emerging UAS or drone market. Um, so the four of us will walk through our analysis of this market as a whole and discuss the opportunities that your firm could potentially benefit from um, by pursuing opportunities in this market.
So the definition of a man-manned aerial system and unmanned aircrafts, as the FAA puts it, an unmanned aerial system is the unmanned aircraft and all of its associated support equipment, a control station, data links, telemetry, communications, navigation equipment, etc., that is needed to operate the unmanned aircraft. The unmanned aircraft is the flying portion of the system, which is flown by a pilot via the ground control system, or perhaps autonomously through the use of an onboard computer and any communication links with any additional equipment that's needed for the unmanned aircraft to operate safely. This diagram shows an example of how the unmanned aerial system works. You have some sort of sensor showing like camera, video camera, etc. that's placed on the unmanned aircraft, which communicates with its ground station via the control and data links. And ultimately, it sends the data down that it collects for storage and/or further analysis. The forms of UASs are as varied as their flexibility. You have the capability to you can have purely anonymous ones that would follow a pre-programmed route or use its computer to avoid missed obstacles, or they can be flown by a pilot at a ground control station or even a team of pilots for long-term persistence. Common all ranges sizes from large, almost full-sized ones to in the future you will even see potentially insect-sized ones. It can have a fixed wing versus a rotary blade. Fixed wings one fly more efficiently. Rotary blades have a more efficient takeoff and landing capabilities. And of course, the price range is also extremely varied. You go from costly unmanned aircraft that are in the tens of thousands of dollars, made from the most advanced space age materials, to what most of them are basically fairly inexpensive, almost model aircraft that are just flown via sight from the ground. And on most of these, you could place a wide array of sensors. Generally, it would be cameras, but you can also put radar and infrared and anything of that nature. According to a study by the Unmanned Aircraft Systems Integration Economics Study, I expect to be over 175,000 civilian unmanned aircraft in the air by 2035. That would create over 70,000 U.S. jobs and more than 13 million over the next 3 years alone. And when you look at the wide range of applications, it's no surprise. There's a broad view of industries that UASs are currently being used in and have potential uses for it as well, ranging from agriculture, mining, law enforcement, delivery companies, construction, films makers, news media, and plenty of other users. It could also be used for wildfire mapping, 3D mapping, all kinds of surveillance mappings, as well as massive data collecting for enhancing future operations. The reason that they have all these uses is due to their capabilities. The ability to take streaming video and pictures. You can plunk infrared sensors on them, radars to either do 3D modeling or look underground, and of course any other sensor type that can be made small enough to place on an unmanned aircraft. They could also be used as a platform for expanding communications. You could put use them to make a temporary cell system expansion. And of course, a few years ago, when Amazon made waves by announcing that they were going to try to develop drones for rapid development, and I'm sure we'll see other companies as well. And I mentioned before, it'd be very useful for large-scale mapping and long-term surveillance and monitoring. All of these new capabilities will enhance the values that the manned aerial systems have for users. So the ability to mount sensors on such a flexible platform allows for many new ways of collecting data that wasn't possible before. Using the continuing advances in sensor technology results in a massive increase in the amount of data that is able to be collected, including in difficult and risky areas for human beings to collect data in now, such as monitoring wildfires or other difficult and remote or rugged terrains from which it is not economically feasible to monitor currently. All of these leads to greater productivity, and especially it can reduce labor costs greatly, and of course the equipment is much less costly than, say, flying manned aircraft to perform similar feats. There's a recent Wall Street Journal article that highlights a Greek real estate mapper who was able to cut down his mapping force from 12 people to 2 people, and has actually increased the amount of terrain he was able to map by utilizing the unmanned aerial systems.
To determine where UAVs fit in the Abernathian Utterback life cycle model, we need to define all 3 phases. The initial phase, which is labeled the fluid stage, is defined by the lack of dominant design, lots of innovation, and the identification of competitors being unknown at this point. The second phase is the transitional phase. The transitional phase is a process innovation dominates versus the product innovation dominating like in the previous phase. The last phase is the specific phase, which is defined by having well-established competitors and tools of competition become based on differentiating costs and product features. UAVs clearly fall into the fluid stage. There are numerous indicators that point to UAVs being in the fluid stage. The overall market is new, emerging market. It is only recently that UAVs for commercial use have come about. Due to it being so new, on the most efficient design is the main focus. Once this has been mastered, we see the process of producing UAVs being improved. But as of yet, this is not the primary focus. Since there is not mass-produced UAVs currently, identifying who the competitors are going to be is still very difficult, which also makes protecting against imitators that much harder. It is evident that there is growing concern for those pioneers in this industry as the application for patents on the components of UAVs in the last decade have increased dramatically. As evidenced by this chart, through most of the dimensions of UAVs are still in the fluid stage, some of the elements such as R&D and the equipment used are already progressing to the transitional stage. In the future, we will see UAS move out of the fluid stage into the transitional phase, which will allow for new innovation to make the production of these devices more affordable. One process that has already made this evident is 3D printing on UAS prototypes. According to an article in the Aerospace Conference written by Glinowski, students at the University of Virginia use this method to make UAS that would normally take months to make and cost nearly $25,000. Theirs cost only $2,000. In addition to make this more time efficient and affordable methods of production, the FAA is already being led to address and start regulating the commercial use of UAVs in the future. This is only going to lower the entry barrier for competitors. The natural leaders are clearly going to be those that have already been in the industry when it came to its military applications, but due to UAS appropriability, there is still going to be room for new entrants in the industry. The commercialization of UAS is also going to open a market for those in the sensory industry, as this is a necessary component of most of these devices.
As an investor in UAS technology, it is important to know when the market will be successful in employing drones to enhance its products and services. For a company to fully employ the technology, it first must determine whether it will be more beneficial than current methods, taking into consideration both quantitative and qualitative factors. This sounds pretty simple, but let's examine a potential example. A hiker is lost in a canyon. Two teams are available for deployment to search and rescue: a traditional team with helicopters and vehicles on the ground, and a team of drones with a ground station. Which team will be more cost-effective, cover more ground, arrive fast enough to save the hiker, over the long run be more effective at finding the hiker? Unlike manpower, drones can perform surveillance on an area much quicker, and unlike helicopters, they can go into some areas that the helicopters can't, like ravines and thick woods. But there are some shortcomings to using UAVs for surveillance. Some UAVs have a time constraint, as they are electrically powered and can't always stay in the air as long as manned helicopters. Also, the quality of the image obtained by the UAV versus that obtained by the helicopter needs to be taken into consideration. UAS technology is fairly new, so employing the technology at a point where time and innovation have progressed enough to allow for a cost-beneficial transition is key. Law enforcement and search and rescue teams, however, might have arguments that cost benefits are to be ignored to some degree, as long as the technology is more effective in the other three areas, as it could save more human lives. Another factor affecting strategy with the technology's development is the concept of appropriability. Technology has loose appropriability and is thus available to most anyone, and thus this affects several other strategic concepts as well. Any first mover advantages may be limited and subject to a learning curve, primarily due to educating the public as to the benefits and functionality, addressing safety concerns, and also privacy concerns, and most UAVs are equipped with cameras. The optimal time to engage in this technology is once the learning curve has steepened and the public's concerns are substantially being addressed. This is soon approaching as the FAA begins to regulate UAV flight. Because the loose appropriability would foster competition among companies in similar industries, this would likely place emphasis on a company's ability to master the use of the technology through component technology, such as those identified here, that would enhance the UAS's features and functionality. Thus, the hiring of key personnel to oversee the implementation would be crucial to the program's success. Defender types would be enabled as their ability to provide products and services effectively and efficiently would be increased. Because the technology is still not widely implemented by the market, features are not fully developed for the wide variety of drone uses. A patent race could likely ensue as manufacturers and developers seek to capitalize on this emerging technology.
Regulatory hurdles, primarily in the United States and Western Europe, that are creating high barriers for entries to new firms in these countries. These challenges would disadvantage US-based firms and could potentially give firms in other nations a head start in developing a technological lead in the drone market. Despite the launch of additional drone test sites, the FAA has not provided clarity around the regulatory environment impacting many commercial drone applications. The limited number of commercial drone testing sites will correspondingly limit research and development for potential firms who do not have access to these 6 sites. The market challenge outlook is improving given the recent breakthrough approvals which the FAA has provided to 4 US firms to operate drones commercially. The major implications are that this bodes well for the future of the industry, as leading experts and investors expect that the FAA will relax restrictions on other commercial drone applications in the near future. This means that any investors considering entering this market on the ground level should quickly ramp up its capabilities in the very near term. In addition to the wider regulatory environment, firms considering entering this market should be sensitive to the public's concerns regarding privacy infringement which may be caused by UAV and drone technology. Regulators could respond to the concerns of the public by imposing altitude restrictions in urban areas, which could rule out some retail and delivery applications of drones altogether. The FAA could thus be more likely to accept automated drones versus those at the mercy of human intervention. These with pre-approved flight plans could decrease concerns for the loss of privacy, as the FAA could get comfortable with the fact that the drone would only be surveilling a certain piece of real estate or it won't go above a certain altitude as to infringe on others' privacy. This method could also reduce the risk of interference with larger manned aircraft. In addition, the GPS coordinates of drones' target location could be transmitted to and cleared, as well as tracked by the FAA on a continual basis. Finally, safety is, of course, a risk to any commercial drone implementation. Commercial drones create risks of property damage, injury, and death, which are possible when operating in large populated areas. Firms entering this market need to be prepared to bear any costs of litigation should their UAVs crash due to mechanical or operator failure. Mitigation of these safety concerns through equipment maintenance and high standards for drone operator training are possible and should be a focus for any firm entering this space. However, U.S. military operators are highly trained and have still caused accidents resulting in millions of dollars of damage. The least risky approach is to invest in automation, which can reduce the risk of operator error. However, this will still require more sophisticated technology and higher initial investments in research and development. Based on the findings of our analysis and research, our recommendation is for your firm to invest in commercial drone products. Despite all the risks outlined, this market is on course to quickly grow once the FAA clears any regulatory barriers. And based on the huge potential market size and growth potential over the next 10 years, firms who enter on the ground level should expect large returns and the ability to quickly capitalize on their initial investment. In summary, firms that make the investment early in order to enter this market and help develop this market should benefit from future potential of the drone as a platform technology which will enable new products and services, which could cause existing firms that decide to go and take this course of action to quickly grow and increase their market share.